In this problem, oh, I forgot to say, this is 12.5.15. So in this problem, we have a rectangular garden that has an area of 480 feet, and it's going to have a brick wall on 3 sides. So here are my 3 brick sides. And we need to have a fence on the other side. Now the brick is going to cost us $12 a foot. So everything in the blue is going to be $12 a foot. And the brick is going to be $12. And the fence is $8 a foot. Now these are all per foot. Now we want to find the dimensions to minimize cost. Okay, now we're talking about a rectangle, so dimensions, width, and height. Let's just do W and X. So this is width, width, well, better make this height. Height, height, width, width. So let's find my area, which is supposed to be 480 feet, and that's just going to be height times width. Very simple. Notice it is constraining us to 480 feet, so this would be my constraint equation. Now they want me to minimize cost, so I need a formula for cost. So cost on this side of the fence right here, we're going to have H feet, and it's $12 a foot. So if you have H feet at $12 a foot, that would be 12H. My next piece would be W feet at $12 a foot, so 12W, and similarly 12H. And on the fence, we have $8 a foot, so 8H, 8W. And this would be my objective equation. The constraint is what actually constrains you. We can only have an area of 480 feet, and the objective is what we're trying to minimize or maximize. So we want to minimize cost, but right now cost has more than one variable, and we don't know how to deal with that. So let's go back to our area, solve for one of those variables, and then come plug it in. It doesn't matter which one you picked. I decided to solve for H. So let's take our area of 480 equals H times W and solve for H. So H is going to be 480 over W. Now let's plug it into our cost. So our cost is going to be 12 times H. Oh, before I do that, let's simplify up here. So this is going to be 24H plus 20W. So coming back down, my cost was 24 times H, but now H is 480 over W plus 20W. Now if I multiply, this is going to be 11,520. And instead of over W, I'm going to write W to the negative 1, just because I know from experience that's easier to take the derivative, plus 20W. Okay, so this is my cost here. Now let's take the derivative. So the first derivative of cost, let's see, when I take the derivative, this negative 1 comes down to multiply, so we have negative 11,520 times W, so I drop the power by 1, so W to the negative 2, plus 20. Now I'm going to set to 0 and solve for W. So 0 is going to equal, now I'll change back to my format of over W squared instead of W to the negative 2. So at this point I'll subtract 20. I can multiply both sides by W squared. And W squared is 576. That means W is either positive 24 or negative 24. This is where you just use a little bit of logic. This is supposed to be the width of a fence. The width of a fence would have to be the positive number. Now technically, you should probably use the first or second derivative test to see if this is truly a minimum instead of a maximum. We don't usually do that in optimization problems. Technically you should. Usually we just kind of skip that step. And so we're going to have a width of 24. And then let's find our height. So remember up above we had h equals 480 over w. So 480 over 24, which equals 20. Okay. Come back up to your picture then. Okay. We put w as a width where the fence is. So we want our fence area. So the fence side to be the w, so 24. And the other side, or brick side, to be 20. So this is going to be 24. This will be 20.